Hello, today I'm looking at M3 International A-Level May 2014. This is question 3. I've got this diagram and it says a particle P of mass 3 kilos is attached by 2 light inextensible strings to 2 fixed points A and B on a fixed vertical pole. Both strings are taut and P is moving in a horizontal circle with constant angular speed of 6 radians per second. So that would be here. String AP is inclined at 30 degrees to the vertical and string BP has length 0.4 and A is 0.4 vertically above B as shown in the figure 2. And then I'm asked to find both of the tension in the upper string and the tension in the lower string for 9 marks. So the very first thing that I will do is draw a diagram of what is happening to the forces on the particle. So I have the particle here, I've got the tension in AP and this other tension in BP, and the mass will act down. I was told that the mass is 3, so the weight is 3g, and I was told it was moving in this horizontal circle with a constant angular speed of 6 radians per second. So for the acceleration towards the centre of a circle, I can use v squared over r or r omega squared, and in this case, because I've been given the constant angular speed, so in other words omega, then I will use this one. So I need to know what the radius of this is here in order to be able to write an expression for the acceleration in this direction. So let's just have a look at what I've got here. If I know that that's 0.4, that's 0.4, then I know that's 30, that's 30. And what I'm really looking for is this length here, so that I can write down the expression r omega squared here. So for the moment I'll write omega squared, but I need to work out r. Okay, so I know that if this angle is 30 with the, hang on, so I've got 30 degrees with the vertical there, because here I've got a z. This angle here is 30, so therefore this angle here is also 30. I know that this length is 0.4, and so this length here is 0.4 cos 30. So now I've got an expression that I can use for the radius here. 0.4 is 2/5, so I've got 2/5 cos of 30 multiplied by omega squared. So the radius times the omega squared there. Here I'm just going to write in this angle that was 30 degrees, and TAP I also know is 30 degrees with the horizontal. So that angle is also 30 degrees. Okay, so now I can start writing down my equations using Newton's second law. So if I look vertically what's happening, then I've got TAP cos 30 plus TBP sine 30 equals the weight. Just tidying that up a bit, root 3 over 2 can replace cos 30. A half can replace sine 30. Okay, and so I've got that equation. Then I can do Newton's second law towards the centre of the circle. Okay, so this time I have the same thing that I had here, except this one will be sine and this one will be cos. So here I've got TAP sine 30 plus TBP cos 30 equals the mass, which was 3, excuse me, times the acceleration, which was this, 2/5 cos 30 omega squared. but I know what omega squared is because they told me. Omega was this 6 radians per second. Here we are, constant angular speed 6. So I can pop a 6 in here in the place of omega. Okay, so tidying up this, sine 30 is a half, cos 30 is root 3 over 2, and here I've got 3 times 2/5 times 6 squared, and then that is multiplied by cos 30. So I've got 216 over 5 times root 3 over 2. So at this stage, it's now just simultaneous equations. So if I write down this equation, number 1 was root 3 over 2 TAP plus TBP over 2 is 3G. And this equation here, I'm going to multiply this one by root 3 so that I will end up with the same amount of TAP. So I'm going to do root 3 times number 2. So if I times this by root 3, I get root 3 over 2 TAP. If I times this by root 3, I get 3 over 2 TBP. And if I times this by root 3, then I will get 216 divided by 5 times 3 divided by 2. And so I get this number. Normally I love fractions, but I'm going to leave this as a decimal now. Because I think I'm just going to type everything into the calculator. So we've got to that stage. And so now I could do this one minus this one. So I'll call this 3, I'll call this 4. So I'm doing 3 minus 4. So that minus that is nothing. Then I've got 3 halves minus 1 half makes 2 halves of TBP, and 2 halves is just 1. And then I've got this minus this, so I have 64.8 minus 3 times 9.8, and that gives me 35.4 newtons. And so that is the tension in the lower string. Then I need to work out the tension in the upper string, so I can just pop this back into here. So using equation 4, then I get that TAP is going to be 3G minus half of this, taking this away, multiplied by 2, and divided by root 3. So then I can just pop all of that in my calculator. So I've got 3 times 9.8 minus the last answer that I got divided by 2. That gives me what is in the brackets, times by 2 divided by root 3. And I get this, which is 13.5 newtons to 3 significant figures. To double check your answer, because this is one of the few questions where you can check your answer, you could now stick those 2 answers in this and just make sure it's working in the other equation that you got, or stick them back into the original equations. You can do that reasonably efficiently using the 2 memories in your calculator, A and B. Stick that in as B, stick that in as A, and then you can type in this equation, or one of those original equations that you wrote. Okay, so that question is worth 9 marks altogether. I hope you found this solution helpful. Good luck with your studies.